Hello everyone, good evening. How are you all? So yes, here we are with the new topic and today we are going to discuss on the topic waves. Here we'll be discussing about the type of waves, that is what is this longitudinal wave, what is this transverse waves, what are these electromagnetic waves, and yes, we are always in the state of doubt. Sir, what is this trough, crust, what is this amplitude? We are going to discuss each and everything regarding that. In the morning session, when we were discussing the previous year questions of SSC, there was a candidate, that was Jagdishwan. He was actually asking sir amplitude and all. So we'll be discussing that again. Now this would be the theoretical section. So yes, let's start with the part. So yes, if I talk about these waves, let's discuss about some of the important terms. First of all comes the amplitude. What is this amplitude? A wave is an energy transport phenomenon. That's true. Now if I talk about this particular amplitude, so the height of the wave usually measured in meters. Now let me make a wave for you. Here if I draw a diagram, just have a look. This is the positive cycle, this is the negative cycle, correct? Now here if I talk about these points, that is the peak points, where the positive one or negative one, these are troughs and crust. Now if I'll just check this height, just have a look, from here till here, it is representing your what? This actually represents your amplitude. Here is written na, height of the wave. So here when you are measuring this height, this means you are measuring the amplitude. Now it is directly related to the amount of energy carried by the wave. So if someone is asking you about two of the graphs, if one of the graph is this one and if one is this one, so this means here we will be having more energy, because here we can see that amplitude is higher, correct? So okay, this was about amplitude. Now the second thing which we are in the state of doubt is wavelength. Now we have understood this wavelength just by the point that it is lambda, it is denoted by lambda. But what is it exactly? Again, let's have a look at this diagram. Again, I'll make this crust and trough in the wave. This wave is actually known as sinusoidal wave. So remember, this is the positive one, this is the negative one. Now, if I'll make the whole wave, so I have to remove this for better clarity. If I'll make this whole wave, it would be quite like this, correct? So see, between any of the two crest or trough, there would be some distance. So let's just have a look. Distance from this location to this location, there might be some distance. Now again, obviously there would be some unit for measuring that, correct? So this particular distance is what? This is actually a wavelength. So the distance between two identical points in the adjacent cycle of a crust of a wave, this is actually a wavelength. Since they have mentioned meters over here, we can use angstrom also, fine, because angstrom is actually the smaller unit in comparison to meters. So yes, here what is wavelength? Again I will say this is the difference, sorry, this is the distance which is there between two of the crust. Okay, next talking about the period. Now what is period? So it is a time of a particle of a medium to make one complete vibrational cycle. Just have a look. If I draw a positive and negative cycle here, so this means a complete cycle is from where? From this location to this location, it is a complete cycle. So there must have been a certain time, correct? Which is in either seconds or minutes. Obviously, in most of the cases, this would be in seconds. So yes, this is actually your period. So if I talk about period, it is the time for a particle of a medium to complete one complete cycle. And if I talk about its unit, it would be either in the seconds or minutes. Now, this was about period. Now let's talk about the wave formation. So particle pulling the next up and down and then again moving down. So this is what? This is actually a wave formation in which the particles which are there, I'll just make a path. The particles which are there, see, they are once up, once they are down. So it is actually making what? It is actually making your whole wave. So yes, positive cycle, negative cycle, crust, trough, amplitude, wavelength, we have understood these things. Now, if I talk about frequency, so what is frequency? We were talking about wave, we have understood this cycle. Now in a single second, how many these cycles can be made? Or in a short manner, I'll say that the number of waves passing through a point in a certain time. Now how you will calculate it? So it is actually the inverse of period. If I'll write the frequency, so it is 1 upon period, and its unit is what? Here we will measure it in the hertz. Fine. So it is actually equal to 1 wave per second. So this was about frequency. Now we have understood about the period, so it is the reciprocal of frequency and vice versa. So we have understood the frequency, so it is exactly the opposite one, that is it is indirectly proportional. So we'll say that period is equal to 1 by frequency. Next, if I'll talk about speed, it's very obvious. Speed is what? We know that speed is equal to distance upon time, correct? So distance is equal to what? Distance is equal to speed into time. So whenever we are talking about the speed, it always means that we are talking about the ratio of distance and time. So here, if I'm talking about the speed with related to the waves, so how fast an object is moving, this is denoted by speed. So speed of a wave, distance traveled by a given point on the wave in a given interval of time, and we are aware of this formula, that is speed is equal to distance by time. Next, now if I talk about the types of waves, please remember the main ones. If I'll write two of the waves, one would be longitudinal, one is longitudinal, another one is transverse waves. Now, no matter we are writing here only two, that doesn't mean that EM waves are missing. We will be discussing about electromagnetic waves also, but before this, let's have the clarity over this part. If I talk about longitudinal, this means if the wave is propagating in this direction, now what will happen to the particles? If the wave is moving in this direction, that this means particles are going to be in the horizontal direction, that is in the parallel direction with this movement of the wave. But if I talk about the transverse waves, if the wave is moving in this direction, then in this condition particles will be perpendicular to this wave. So there's a difference between two. Now what can be its example? If I talk about longitudinal wave, you can talk about sound waves over here. But if I talk about transverse waves, so here you can talk about water ripples. So if I talk about the water in the pond, so those water ripples would be its example, where what happens, I'll just make the diagram over here. If we are throwing anything into the pond, what will happen? The waves will start moving forward, but the particle which is present here, it will move in this direction. So the wave is moving forward, but the particle which is there in the pond will be moving in this manner. That means it would be perpendicular to each other, correct? So yes, that is the transverse waves, and if I'll talk about the longitudinal, that is the sounds example. So let's start with our discussion. We were talking about transverse, we understood this. So here, medium moves at the right angle to the direction of the wave. This means what? Right angle means what? We are talking about the perpendicular, correct? That is your 90 degrees. So here, electromagnetic waves, if I'll talk about its example, it can be string instrument where you can talk about the guitar, and yes, this water ripple is also its example. This is actually asked in the examination. In the ending of the session, around 6:40, we'll be having the discussion of those particular important questions which are previously asked. So all these questions are previously asked. Please remember, because we'll be having discussion in the ending. Yes. Next. Now let's talk about longitudinal wave. We were discussing about longitudinal wave, right? If the wave is traveling in this manner, then the particle will be traveling parallel to it. So here, if I talk about the movement of particles, so movement of the particles in the medium in the same dimension as the direction of the movement of the wave. What is its example? Its example is sound waves, where there is a continuous compression and rarefaction. That is, if I talk about these sound waves, so when I am talking with someone, there are particles, air particles which are present over here, correct? Which we are unable to see, but they are there. Now when I'll speak something, so the particles which are just next to my mouth, it will be present there and it will start vibration. So here another particle is there, then another particle is there, and in the similar way what is happening? So there is a contraction and rarefaction, because of which others are able to listen, because of the particles which are present. That's why it is said sound waves cannot travel in the vacuum. Why? Because there are no such particles, correct? So yes, here sound waves or the compression waves would be the example of longitudinal wave. Simple. So we have discussed about the transverse waves and longitudinal waves. Okay, so let's move forward now. Now talking about the electromagnetic waves. So here periodic changes that take place in the magnet and the electric fields, they don't require any medium for propagation. This is an important point. Please remember, EM waves doesn't require any sort of medium. Now, we studied something like this earlier. Remember the heat chapter, where we were discussing the modes of propagation of heat, where we discussed convection, conduction and radiation. Where in the radiation part we understood when we are talking about the energy that is coming from the sun to the earth, there is no such medium required. True. So, sorry. So that was the part with the radiation. Here, if I talk about the electromagnetic waves, remember it doesn't require any object medium for the propagation. Now, if I talk more about it, they can easily travel through the vacuum. Why? Because we have understood they don't require any such medium. Then they are produced due to various magnetic and electric fields. So here magnetic fields and electric fields are involved, but the important thing is that they can travel through the vacuum, that is, they don't require any sort of medium. So this is about electromagnetic waves. Now if I talk about this example, then they are gamma rays, X-rays, ultraviolet rays, visible rays, infrared rays, microwaves and radio waves. So yes, these are the waves which are there in the electromagnetic waves. So I'll just explain about it. Is there any sort of doubt? If there is any doubt, please let me know. If there is any doubt, please let me know so that we can proceed forward now. So who all are there? Kindly comment so that I can start conversation with you. And yes, everyone who is there in the class, kindly like this session and share it. So yes, if I'll talk about this electromagnetic waves, there were gamma rays, X-rays, ultraviolet rays, visible rays, infrared rays, microwaves and radio waves. Now let me write for you all. This GXUVIMR. Please remember this particular short form, or if you can remember all these in the sequence order, it's good. But please remember GXUVIMR. So this GXUVIMR represents what? G is for gamma rays, X is for X-rays, U is for ultraviolet rays, V is for visible rays, I for infrared, M for microwave and R for radio waves. So this is the sequence order. Fine. So do not forget. And yes, everyone who has joined the session, kindly like it and share it. So yes, we are talking about the electromagnetic waves and this gamma rays, X-rays, ultraviolet, visible, infrared, microwave and radio waves. These are in the sequence order. And we need to remember this because if I talk about the increasing of the wavelength, so see, if I talk about the maximum power, so here penetrating power is of gamma rays, the maximum energy which is present is of gamma and it keeps on decreasing as we move forward. So yes, the sequence order is very, very important. Let's move forward now. Talking about this sound wave. Now this sound wave we have discussed. What is it? It is the longitudinal wave. Now, how we are saying it is longitudinal wave? Because we have discussed this part. When I am saying something, this means there are molecules which are present nearby me. And while speaking, there would be molecules that are in front of my mouth. They'll be just contacting with the next molecule, then with the next one. And in the similar manner, what is going to happen? This contractions and rarefactions, compressions and rarefactions will lead to another person's hearing. That is, this particular process will allow another person to hear my thing, correct? So yes, this is a pattern of disturbance caused by the energy traveling away from the source of the sound. And it is the example of longitudinal wave. Here what is happening? If I talk about the propagation of wave, the particles are traveling parallel to it. So the propagation of vibration of particles is parallel to the energy of wave propagation direction. Understood? Just have a look. This is the parallel way in which they are propagating, and everyone who has joined the session, kindly like it and share it. So yes, next, what is a sound wave? Sound waves are mechanical waves which always need a medium. This means what? If I talk about the vacuum, please remember this sound wave will never travel in the vacuum. Why? Why it is not traveling in the vacuum? Because there is no such medium in the vacuum. It's as simple as that. So yes, if I talk about the sound intensity, it is measured in decibels. It is measured in decibels. Next, if I talk about the audibility range, so see, if I talk about the audibility range, this means we are talking about what? We are talking about that range that we can hear. So here, audibility range, if I talk about ultrasonic range, ultrasonic waves, here the sound frequency which is there is of above 20,000 hertz. So yes, ultrasonic is the range where sound frequency is above 20,000 hertz, or rather I can say 20 kilohertz. Now there must be someone who can hear this, right? So here dogs and bats can perceive these sounds. So dogs and the bats are the ones who can perceive the sound. But if we'll talk about the human ear, if I'll talk about the human ear, that is the audibility range of a human ear is of what? Here the range is exactly of 20 hertz to 20,000 hertz. Okay, so above 20 hertz, above 20 kilohertz, dogs and bats can perceive these sounds. Now talking about our range. So our range is within the audible range, which is exactly 20 hertz to 20 kilohertz. But we are talking about what? Infrasonic right now. So for the infrasonic waves, here we have the sound frequency of below 20 hertz. So here, who would be the example? Here the example would be of hippopotamus. So hippopotamus and elephants perceive this sound. Again I'll write the range. If it is between 20 hertz or if it is below 20 hertz, here hippo or elephant would be the example. If it is between 20 to 20k, that is 20,000 hertz, here humans can be the example, that is we. And if I talk about above 20 kilohertz, above 20 kilohertz, so I write here above 20 kilohertz, here you can talk about the bats or dogs. So this is the range exactly, so please remember this part. Okay, so here hippopotamus and elephant can perceive the sound. Both ultrasonic and infrasonic sounds are not audible to human ears. That is, neither we can hear this range, neither this range, but we are under this particular range, that is 20 to 20,000 hertz. Fine. So yes, this is the part. Now talking about echo. What is this echo? If I talk about this part where we are talking about echo, so it is the sound heard after the reflection from a distant obstacle, which can be a cliff, it can be a hillside, it can be anything, where there must be some sort of distance. There is a minimum distance which is required is of 17 meter. So here again I'll say sound heard after the reflection from a distance obstacle after the original sound has ceased. So just have a look. Here a person was speaking something, fine. Here the person was speaking something and this hit the obstacle and it again came back. So when a person is speaking something, he has stopped saying that. But after the reflection, the sound again came back. Now this is the question which is asked in the examination. What is the minimum distance that is required? The minimum distance that is required is of 17 meter. Very important. Please do not forget, because this is directly asked in the examination. What is that range? So yes, this was echo. Now if I talk about the condition of this echo, so the condition is the reflecting surface in the air should be at a minimum distance of 17 meter from the listener, or the reflected sound should reach the ears 0.1 seconds after the original sound is ceased. So when the particular person has stopped saying something. Now here we can take the example, but before taking that example, who all are present here, kindly give me your name so that I can give the example of anyone's name. Who all are present here? Who all are present here? Can you give me your attendance, please? Okay, so we can take the example of any of the person who is standing on a hillside and he's shouting something. So if I'll take the example of a Rohit. Let's take an example. If there's a person who is Rohit over here, and this Rohit has started speaking something. Okay, so Megha is here. Okay, cool. So we have Megha over here. Okay, so what I was talking, there is a person who is Rahul over here. Now Rahul is shouting something. Let's take an example. He is shouting his name. So when he is shouting his name, he is saying Rohit. Now what will happen? He has stopped saying that. But there's a sound which is again coming back. That is Rohit, Rohit, Rohit. So the sound which is coming after the reflection, of this Rohit is actually echo. Fine. So yes, that's the thing. And when he'll get that sound, he'll be getting that sound in within 0.1 seconds. Okay, so this was echo. But there's one more thing that is different from echo, and that's what is known as reverberation. If I talk about the distance, that was of 17 meter. Minimum distance that was required for the echo was 17 meter. But what if the distance is lesser than 17 meter? So here that condition will lead to reverberation. So if the distance is less than 17 meter, then the original sound mixes with the reflected sound, and this effect is known as reverberation. So there's a difference between two. If I talk about the distance of minimum 17 centimeter, echo will be there. But if the distance is lesser than 17 meter, then this will be known as reverberation, and Here we can take the example of a room where you are speaking something and whatever you have spoken, that particular sound is again coming back but with the lesser intensity. So that is reverberation. Okay, now we'll move forward. So if I talk about the uses of echo, so echoes are used by bats, dolphins, and here the concept which is used, here we'll talk about sonar. So there's a full form of sonar which is actually asked in the examination, and this full form is sound navigation and ranging. If I'll talk about radar, so there's a full form of radar. What's that? The full form of radar is radio detection and ranging. So yes, these are the uses of echo, where bats, dolphins, they are actually doing what? They are sending the waves, and once these waves are sent, they'll be getting that wave again. So the time duration in which they are getting that particular wave back, they totally understand, okay, so there's an obstacle around them, so that's why they are moving accordingly. So yes, echoes are used by bats and dolphins. Next, other uses of echo are in the medical science, in ultrasonography, then there is echocardiography, which is the imaging of human organs. These all are the uses of echo. Okay, let's move forward now. We'll be having now question answer session. Let's start with those particular questions. So there's a first question. When a stone is thrown in calm water of a pond, waves produced are what? So are these longitudinal wave, transverse waves, both A and B, or wave doesn't get produced? So what is the answer over here? When a stone is thrown in a calm water of a pond, waves produced are what? So are these longitudinal waves, transverse waves, both A and B, or D? That is, wave doesn't produce. So what is going to be the answer over here? I'm waiting for the answer from everyone. Yes, so we don't have an answer over here, but let me tell you, when we are talking about a stone that is thrown in a pond of water, this will create what? There would be a wave that would be proceeding forward. But whatever object is there on this particular position, it will keep on moving up and down. This means if I'll talk about the propagation, direction of the propagation, this is exactly perpendicular, correct? So if I'll talk about these waves, we were understanding when we understood about the longitudinal wave, the direction in which sound was traveling, if it is parallel, that is the motion of the particle is parallel, this is the longitudinal wave. But when we talk about the transverse waves, these are perpendicular to each other. So yes, here transverse waves would be the correct answer. That is option B is going to be the correct one. Next, moving forward to the next question, and everyone who is here, kindly give me your attendance so that we can start talking. Next, these waves cannot be transmitted through vacuum. So which is that? Is it light, heat, or electromagnetic wave, or sound wave? Which particular wave cannot be transmitted through the vacuum? Waiting for the answer. Which particular wave can be which cannot be transmitted through the vacuum? Is it light, sound, heat, or electromagnetic wave? So we were discussing about it, right? So if I'll talk about the waves which cannot be transmitted through the vacuum, here we know that if I'll talk about vacuum, this means there is no such medium, correct? If there is no such medium, it's only the sound waves which can propagate, correct? So here I'll talk about sound waves. So sound wave can also, these waves cannot be transmitted through the vacuum. Okay, so if I'll talk about the vacuum, so if I'll talk about the sound, so we cannot conversate with each other if there would be no such medium, correct? So yes, we have discussed about it, and here the sound is going to be the correct answer. Next, which of the following waves cannot be polarized? Is it radio, ultraviolet, infrared, or ultrasonic? And till the time I get the answer, let me tell you, for the polarization, we need a wave which would be what? Which would be longitudinal in nature. Longitudinal. And if I just check the options, which particular wave is actually longitudinal? So we are aware of sound is longitudinal wave, and here ultrasonic waves are actually the waves which are from the sound part, that is they are the longitudinal. And polarized waves the waves which cannot be polarized are longitudinal. Here sound waves, that is option number D, is sound. That means it is longitudinal in nature and hence it cannot be polarized. So option number D, that is ultrasonic, would be the correct answer. Next, Which one of the following is not a electromagnetic waves? We just discussed about it. Now this question is from CGL. Remember what we were talking? If I'll talk about EM waves, that is electromagnetic waves, we have G, X, U, V, I, M, R. That is gamma ray, X-ray, ultraviolet ray. Remember all those things? So if I'll talk about this particular sequence order, just try to have a look. If I'll write X-ray, it is there. Gamma ray, it is present. Then infrared ray, it is there. But the thing which is actually odd one out is what? Here, yeah, Megha has given answer D. But here, cathode ray would be the correct answer because cathode ray is actually not present here. Fine. So yes, cathode ray is the correct answer. I guess you got this point. So please remember the sequence order. G, X, U, V, I, M, R. From this, you will be getting this clarity. Next, which of the following has the lowest frequency? So which one is it? Visible ray, gamma ray, X-ray or ultraviolet ray? So waiting for the answer. Just have a look for this answer. G, X, U, V, I, M, R. So if I'll talk about the lowest frequency, just have a look at this sequence order and then answer. So what is going to be the correct answer? What is going to be the correct answer over here? Is it gamma ray, is it visible ray, is it X-ray or ultraviolet ray? What is going to be the correct one? Okay, so see, if I'll go with the sequence order, we know that this is going to have the highest energy. I'll write about the energy. In the starting, we are having the highest energy, but as we proceed forward, the energy goes in getting low. So this means, according to these options, gamma ray is there, but it is having the highest. Then we have visible ray, which is over here. Then we have X-ray, which is here. Then we have ultraviolet ray, which is here. Now, in this particular sequence order, we know that this would be of highest energy. It will become lower. So here we will be having less energy according to these options, correct? So yes, according to these options, option number A is going to be the correct answer. So it's as simple as that. Just go with this particular sequence order, everything would be sorted. Okay. So here option number A, that is visible ray, is the correct answer. Now, let me tell you about the example official application. It is one-stop solution for the government job aspirants. We have live paid courses with the test series. Then we have free subject-wise and topic-wise quizzes with the report card. We have job alerts, admit cards, examination dates, all exam previous year PDFs with the solution. Then we have free All India scholarship test with the report card. We have topic-wise free live classes, free full-length and sectional tests with the report card. We have free examination-wise PDFs and practice at PDFs. Then daily, weekly and monthly current affairs, unlimited subject-wise practice questions. All these things at just one stop. How you can download it? Just go to the Play Store, type Example there, click on the install button, click on the open part, just register it and start using it. And yes, after the registration, you can start using it. If you have any doubt, comment section is always there for you. Okay, so every hot object emits what? So we have the options X-rays, visible rays, infrared rays, ultraviolet rays. What is going to be the correct answer? X-rays, visible rays, infrared rays or ultraviolet rays. What is going to be the correct answer? Every hot object emits what? What is going to be the correct answer? Every hot object emits what? Is it X-ray, visible ray, infrared ray or ultraviolet ray? So here, if I talk about every hot object, it emits infrared ray. That is option number C would be correct over here. So yes, option number C is correct. Next, which of the following is not true about X-rays? They have low penetrating power. They travel with the speed of light. They can be reflected or refracted. They can affect photographic plates. So please have a look at not. This means we have to take out the wrong statement about X-rays. So please, waiting for the answer. What is going to be the correct one? Waiting. See, if I talk about the X-rays, we know that X-rays can travel with the speed of light. They can be reflected or refracted, and also they can affect the photographic plates. The only option that is not correct is what? Option number A. That is, they have low penetrating power. So option number A would be correct answer over here. Moving forward to the next question. Which of these travels in the glass with minimum velocity? Now for understanding this question, we must understand the sequence order. What's that? That is Vibgyor. The sequence order is of Vibgyor. Now if I'll move forward, this means in this manner, if I'll talk about the velocity, so the minimum velocity is here. But as soon as you will move forward, it will go on increasing, correct? And if I talk about the scattering power also, so for the scattering power, this violet light is with maximum part, but here the red light scatters with the minimum part. So this means we have the minimum scattering for the red, but according to the question was which of these travels in the glass with the minimum velocity. So it's the which light would be the minimum with the minimum one? So here violet light would be there with the minimum velocity. So this sequence order of Vibgyor is important. Please remember, because of this fact, that is red is scattering the least. That's why this red color is actually used in the danger signals. Whenever we are talking about the danger signals, we know about red light because we can have a look at this red color from far behind because it is not going to scatter. That's why we are using it in the danger signal. So we have Abhishek here. Hello Abhishek, good evening. How are you? So yes, this is the correct answer. Next, indicate the correct arrangement for the electromagnetic radiation in the order of their increasing wavelength. Now if you'll go with this question, just have a look at the sequence order. What is that? GXU, VI, MR. Now, if I talk about the sequence order we are aware of, as soon as we'll start moving forward, we'll move forward. Here in this sequence order, our energy will be increasing. The wavelength would be increasing. So here we have the maximum wavelength with the red part. So let's see who will give this answer using this concept. So yes, Abhishek, how are you? Waiting. Will it be option A, B, C or D? If I'll go with the sequence order, I know that X, I, V, M. Is there any option? X, I, V, M. No, there is no such option. That means it would be wrong because we are talking about the sequence order, right? If I'll talk about option C, V, I, M, X. V, I, M, X. That's also not possible. So this is also going to be wrong. Now, X, V, I, M. X, V, I, M. And yes, the option is for the increasing wavelength. That's true. I was talking about the maximum wavelength, which was of red. So when I'll go in this sequence order, that is X, then V, I, M. This is going to be the correct answer. That is option number B will be correct in this scenario. Got my point? So if there's any sort of doubt, please let me know. And everyone who has joined this session, kindly like it. Yeah. Then there's a question, matter waves are what? Matter waves are what? See, if I'll talk about this de Broglie waves, then this means what? Here we are talking about both nature, that is particle nature as well. Particle nature plus we have here what? And wave nature. Particle nature plus wave nature both. I am also good, Abhishek. I am also good. So yes, I was talking about this matter waves. So these are actually de Broglie waves. So please remember, they are having what? They are having both the natures, that is the particle nature as well as the wave nature. So option number A was correct here. Next, which electromagnetic radiation is used for satellite communication? So for satellite communication, we are using what? So we'll talk about the satellite communication. Satellites are actually of two different types. Satellites are of two different types. One is polar satellite. Another one is geostationary satellites. But there's a difference in the range of their orbits. If I talk about this geostationary satellites, it's at 36,000 kilometers. But these polar satellites are around 1,000 kilometers. But since we are talking about the satellites communication, so for satellite communication, we need to cross the ozone layer which is present here, correct? So here please remember, the waves which are actually used, or I'll say electromagnetic radiation which is used here would be what? Microwave. That is option number C will be correct over here. Next, ultraviolet radiations of the sun do not reach the earth because Earth's atmosphere is surrounded by dash. Now this question is from SSC Section Officer 2001. So what is going to be the correct answer over here? Yes, waiting for the answer. If I talk about the ultraviolet radiations of the sun, they are not reaching the earth because earth's atmosphere is surrounded by what? Is it carbon dioxide, ammonia, chlorine or ozone? When we talk about these particular examples, we are aware of what effect, that is greenhouse effect. True. If I talk about air conditioners, we have CFCs over there, chlorofluorocarbons, because of which there's a depletion in ozone layer. Now what happens if I talk about a sunlight? There's a sun and here's the earth. When sunlight is reaching earth, we have a covering over here and this covering is of O3. Abhishek is with carbon dioxide. Abhishek, sorry, but it would be ozone. Please try to understand this part. If I talk about this layer, it is ozone, that is O3. Fine. Now this O3, that is ozone, which is present here, it is preventing this ultraviolet radiations to reach the earth. That is, it is keeping us safe and sound. Now there's one more question which is asked in the examination. If I talk about its width, please remember, when we're talking about the width of this ozone, this question is again and again asked in the examination. The width which is there of the ozone, this width is actually measured by Dobson. So there's an option that is given in the examination. Is it kilometer? Is it meters? So please remember that would be Dobson. So the width is measured in Dobson. It is ozone which is actually preventing you from the ultraviolet radiations. So the question was, ultraviolet radiations of the sun do not reach earth because of what? Because earth's atmosphere is surrounded by ozone, which has the formula O3. So your option number D is going to be the correct answer. Next, gamma rays can cause what? Now this is from CPO 2002. What would be the correct answer? So we have Jaya here. Hello Jaya, how are you? Yes, there's a question. Gamma rays can cause what? So see, if I talk about these rays, we'll be discussing radioactivity. In the radioactivity part, no issues. There's no need of sorry. I was just explaining. It would be beneficial for you because here you are giving the wrong answer. But in the main examination, you will be 100% correct. Okay. So I was talking about the point here. If I talk about gamma rays, please try to understand. We'll be understanding this in the radioactivity as well. We have alpha ray, beta ray, then we have gamma. So we'll talk about these gamma rays. These are actually, if they enter into a body, what they are going to do? We have DNA structure in our body, correct? Remember ACTH. So if it enters into your body, it will do what? This particular part, if there is any alternation, there would be alteration in your DNA, and hence we can say that they will be doing gene mutation. So yes, Jaya, you're absolutely correct. The correct answer is going to be gene mutation over here. Next, ultraviolet radiations has more energy as compared to dash. Now this is from SSC Section Officer 2002. So who will give this correct answer? And everyone who has joined the session, kindly like it and share it. And all these questions were previously asked in the examination. So each and every question plays a significant role for the selection. So yes, if I talk about the ultraviolet radiations, they are having more energy in comparison to what? Now what happens? As soon as we see these type of questions, we try to skip them. But trust me, these are very simple. What we have to do, we have to just remember that sequence order. Remember that. What we were saying, we were discussing about GXUVIMR. Now try to relate it. What we are asked? We are asked about the more energy in comparison to ultraviolet. This is ultraviolet. Now if I'll go with the, we have gamma, we have X-ray, we have visible ray over here, infrared ray over here. So if I'll just try to compare, what is going to be the answer? Abhishek is saying, sir, it would be gamma radiation. Others? Are you also with gamma? Jay Raju, are you also with gamma? Waiting for the answer. I guess you have already given answer A, huh? It is infrared. Sure? Yes, and everyone else who has joined the session, kindly let me know the answer. So Megha has another option that, sir, it would be B. Huh? Okay. And others? We have understood this with the sequence order. Remember? We are talking about the energy levels. Okay, cool. And others, all the 5 candidates which are there right now, I request everyone to kindly like the session and share it so that we can have more people over here and we can discuss this question. Everyone. Okay, so you all are okay. So you all are going with this option A. Yes, if I'll go with this part GXUVIMR, please remember when we are moving forward, this means we are talking about the increasing level of energy. Remember, increase. There would be increase in the energy, and if I'll check the increase level in the energy, if I'll talk about this, we are comparing with the ultraviolet ray. So this means what all options are there? Infrared, which is above that, but gamma and X-ray are before that. So ultraviolet ray is having more energy in comparison to what? In comparison to this. Sorry, I have written it in the opposite direction. Energy will increase in this direction, correct? So if I'll compare it with this infrared ray, it would be obviously it would be greater than this infrared, correct? X-ray would be greater than this, and gamma is with the maximum one. So yes, option number A, that is infrared, would be the correct answer, because it is asking ultraviolet radiations are more than which part. So obviously in this direction we will move forward. So here ultraviolet is more than the infrared. So option number A would be the correct one. Next, ultraviolet rays can be used in water treatment for what? As a what? So this is from CHSL. If I talk about ultraviolet rays, if I talk about water, if we have microbes in the water, so what these UV rays will do, they will act in such a manner that these bacteria, these viruses will not able to reproduce. Fine. So yes, there will be it will be acting as a disinfectant. Is there any such option regarding that? Yes, option number C. So ultraviolet rays can be used in water treatment as a disinfectant because there would be no more microbes after this. Okay, so yes, Jaya, absolutely correct. Option number C would be the correct answer. Next, who discovered X-rays? A very important question. I don't know how many times it is asked in the examination. Now, if I talk about this X-rays, please remember X-rays were discovered by, okay, so I'm waiting for the answer actually. First, let me get the answer from you all. Then I'll discuss about all the other options. So if I talk about the X-rays, please remember it's not only about this Tax Assistant 2009. Apart from that, CHSL, MTS, CGL, no matter what exam it is, but we get this particular question. So yes, what is going to be the correct answer? Here, Jaya is correct, totally correct. That is Roentgen. What is his full name? Full name is William Roentgen. So William Roentgen was the one who has discovered X-rays. But if I talk about this Becquerel, full name is Henry Becquerel. He was the one who has discovered what? Radioactivity. What? Radioactivity. But if I'll discuss about this Marie Curie, so Marie Curie and her husband Pierre Curie discovered what? A very important part. That was radium. And Marie Curie was the one who has taken a. Avan, I am unable to get your language. So can you please use Hindi or English so that I can get your point? So yes, if I talk about this part, Marie Curie, she was with her husband when she discovered radium. And please remember that Marie Curie is the one who has got the Nobel Prize more than once. Acha, you have written Assalam Walaikum, okay. Walaikum Assalam then. Okay, so Megha was with William Roentgen. Then Jaya Singh said, yeah, more than once she has got the Nobel Prize. Fine. Okay, then moving forward. Then we have which of the following is used in MRI machine. Now this one is important. If I talk about these MRI machines, fine. So from the name itself, you can get this answer. So just try to get this answer. So Avam, Jaya, let's see who gives this answer. Abhishek, we have Megha over here. What is going to be the correct one? Which of the following is used in MRI machine? See, from the name itself, we'll be getting this answer. Okay, Abhishek, okay, fine. So yes, if I talk about this MRI machine, from the name itself, from the full form itself, that is magnetic, we can relate it. Yes, Jaya, that's totally correct. Option number D would be the correct answer. So MRI machines actually use the magnetic waves, that is option D would be correct here. Next, a wavelength of 0.3 meter is produced in an air and it travels at a speed of 300 meter per second. Then it will be in what? Now this is from CHSL 2005. Is it audible wave, ultrasonic, microwave or infrasonic? So Avan has given the answers ultrasonic waves, and here Jaya was with magnetic. Yeah. So Avan, that was magnetic was the correct answer. From the name itself, we can denote it. Fine. So okay, that's great that you have given the answer, but I'm sure that in the main examination you will be correct over there. Fine, Avan Tariq. Okay, so I'll come back with my point. So there's a wavelength that is given of 0.3 meter and it is produced in the air. It is traveling with the speed of 300 meter per second. Now it will be what? Will it be audible wave, ultrasonic, microwave or infrasonic? Now for measuring this, arey wow, that's good. You have given its full form. Magnetic resonance imaging, correct? True. So that's why I was saying from the name itself, magnetic, we can relate it with this part. There's no need of sorry, man. There is no need of sorry. It's good that you are giving the answer. And that's important because once you're wrong here, I'm sure you will be correct in the mains examination. Good that you attempted this. Let's try to solve this part. Now for understanding this, I have a point. See, when I'm talking about the wavelength, so we have a wavelength of 0.3 meter, correct? If I talk about speed, so we have given the speed of 300 meter per second. Now this is the question I know. It was asked in the CHSL, but it seems as if it is of a higher level, but it's quite simple. Just try to relate it. Okay, great. Okay, Avan, cool. So what I was talking about, and he's a great faculty. Yes. So let's come back to a point. When we're talking about this wavelength, so how you are going to measure this? Sorry, if I talk about the frequency, how you will measure this frequency? Frequency can be measured by your speed divided by the wavelength, correct? Now if I divide the speed from the wavelength, what I'll get? It is 300 meter per second and the wavelength is given what? 0.3. Now just try to solve it. If I'll try to solve it, just remove this decimal over here. It would be 1000, correct? 1000 hertz. Now we have just discussed, if I'll talk about the audible wave, its range will be of what? This range will lie between 20 hertz and 20,000 hertz. And we understood that also, if it is below 20 hertz, the hippopotamus was listening that sound. If it would be above 20,000 hertz, then we were talking about the bats over there. But if I talk about humans, audible range for us is between 20 to 20,000 hertz. And 1000 is lying between 20 and 20,000. That's why we will have audible wave as the correct answer. Does anyone has any doubt in this particular calculation or in understanding this part so that I can explain that again? Is there any sort of doubt? Please let me know because we'll be having last question after this. So is it clear? Avan Tariq, Jaya Raju, Megha, Abhishek, is there any sort of doubt? So we have Phenomenal over here. Hello Phenomenal. Good evening. How are you? So yes, if there is any sort of doubt, please let me know so that I can explain this part. So yes, in this manner you can actually calculate and understand what is exactly the value and accordingly you will be clicking that answer. Okay, cool. Okay Jaya, fine. Let's move forward now. So this would be the last question for the day. Bolometer is used to measure which of the following? Bolometer is used to measure which of the following? Now this question is from SSC Tax Assistant 2009. Okay Mega, fine. Okay Avan, cool. So yes, if I talk about the bolometer, remember bolometer is used for measuring the temperature. That is option number B would be the correct answer. Fine. And please, I am saying this part again because all these things are asked previously in the examination. Okay. So what all things we discussed today? Let's have a conclusion with this. We started with the waves where we discussed, if I am talking about the longitudinal wave, the direction in which wave is propagating, the molecules will be propagating in the direction parallel to that. If I talk about the transverse waves, the molecules propagation would be perpendicular to the direction of the wave. Then we discussed about electromagnetic waves, right? Where we had G, X, U, V, I, M, R, that is gamma ray, X-ray, ultraviolet ray, remember? So there, please remember, this sequence order is of extreme importance, G, X, U, V, I, M, R. Here, whenever question is asked, if you remember the sequence order and where we are having the highest energy, where we have the lower energy, that is very important to understand because in the examination, once you get it, you will be clicking the correct answer. And then we understood about the sound waves. Remember that? Now in the sound waves, let me tell you, if I talk about this range, please remember the range. If it is below 20 hertz, only and only hippopotamus or elephants can hear, we can't hear. If it is between 20 hertz to 20 kilohertz or 20,000 hertz, we can hear. That's why we say that it is the audible range. But if the range is above 20 kilohertz, 20,000 hertz, it's the bats and dogs which can hear that. So these are the important things which we must know. Fine. So these were the important things. Tomorrow morning, we'll be having the discussion on the previous year questions of light topic. That is, whatever was asked from the light part, whether it is CPO, Steno, CHSL, we'll be discussing that. And in the evening, we'll be having theoretical section as we have always between 6 to 7. Till then, bye-bye everyone. Please take care. Enjoy your day.